Hello, welcome again to probability. My name is Professor Mike, and it's a continuation from the first video I made, probability. Okay, so we're going to solve probability problems. We're going to solve two probability problems in this video. Okay, a letter is chosen at random from the letters A, B, C, D, E, F, and G. Calculate the probability that the letter chosen will be a consonant. Okay, so from the previous video, we learned that probability, it's a likelihood that something will occur. It's a chance of something happening. Okay, so let us first make a possibility. What is our possibility space, or what is the set of our outcomes? So possibility space, okay, this is probably the solution then. So possibility space will have A, B, C, D, E, F, G, and H in our possibility space. Okay, so this is our possibility space, the set of all our outcomes. Okay, so we can see here that the letter is chosen at random, which means it is just chosen anyhow. We don't have that preference, that choice. We are not given the chance. Okay, we are just selecting just anyhow. Okay, so we would not know which letter that we would pick. So A, calculate the probability that the letter that is chosen will be a consonant. A consonant. Okay, so a consonant. So let us see. View a set for a consonant. So in this set of possibilities, or the set of our outcomes, we can see that the consonants, the vowels, it's A, B, R, A. These are the vowels, and the consonants, the rest are the consonants. So the vowels, it's R, A and E. These are the vowels. The rest, we call these the consonants. So the probability that the letter chosen will be a consonant will be equal to how many letters we have to write, then the number of outcomes in our possibility space. 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 8 outcomes from our letters, we only have we have 5 chances out of our 8 outcomes of getting a consonant. Okay, so that is, so we can see here 1, 2, 3, 4, 5, 6. I mean, we have 6 chances of getting a consonant. Okay, so out of our 8 outcomes, we equally have 6 chances, or 6 possible outcomes of getting a consonant. So if we would reduce this would be 2 in here, that's a 3, 2 in here, that is a 4. So this is the simplest way we can reduce this. Okay, so we only have 2 vowels in our possibility space. 2 vowels in our possibility space, the rest are consonants. So the possibility space is made, most of it is made up of consonants. Okay, so let's go to B. Not keeping in mind that probability is just the likelihood of something happening. Okay, so 6 is the likelihood or the chances of us getting a consonant out of our 8 outcomes. This is the total number of outcomes, but in these outcomes there are 60 chances of us coming across a consonant. Okay, now B, a vowel. A vowel, the probability of choosing that the letter that we choose at random is a vowel. So as we can see here, how many vowels do we have? It's just 2, A and E. We said previously that the rest are consonants. So this we can simply say, out of 8 outcomes, the chances of us picking a vowel is 2. Okay, the chances of us picking a vowel is 2, which is reduced to 1/4. You can see here that just this set of outcomes, the possibility of getting a vowel is simply low than the possibility of coming across a consonant, because the set is made, most of it is made of consonants, is made up of consonants. Okay, so C. Okay, so we have to find the probability of not picking F, okay, G or H. Okay, so to find the probability of not picking F, G, H, or G or H, we have to find the probability. Okay, you have to first find the probability of picking a letter. Then we subtract it. Obviously, we say minus the probability. Okay, we say minus the probability. Okay, so minus the probability picking F, G, or H. So if we find the probability of getting a letter, of picking a letter, minus the probability that the letter that we've picked is minus the letter of minus the probability of picking G, H, or F, G, or H. Okay, so let us do that. Okay, so we are on C. Okay, so C, we have to find the probability of not F, G, or H. Remember, our possibility space, if I write possibility is equal to A, B, C, D, E, F, G, H. Okay, so what we do here is that we say the probability of picking a letter here, this would be how many? 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 outcomes, they will also have equal chances that the probability that the letter that we will pick, that the one will pick, it's a letter, so which is 1. So the probability of picking a letter is 1. So from there we calculate the probability of picking G, picking F, G, or H. This would be 1 over 8, okay, 1 over 8 plus 1 over 8 plus 1 over 8. So this is the probability of picking F, so the probability of picking G, and the probability of picking H. Okay, so this would be okay, this is 3 over 8. So let us just subtract. So this will be equal to 1. So probability of not F, G, or H. Just have to subtract. So we can say 1 minus 3 over 8. So this would be 8 minus 3 over 8, which is 5 over 8. Another way we can do this, actually, we can do it individually. We simply say the probability of picking A will be 1 over 8. The probability of picking B, it's 1 over 8. The probability of picking C, okay, C is 1 over 8. The probability of picking in of picking a D here, a D letter, will be equal to, probability of picking a D letter will be equal to 1 over 8. The probability of picking a C letter, so this would be 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5. Okay, probability of picking E will be equal to 1 over 8. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is 5. 1, 2, 3, 4, 5. This is 5 over 8. Okay, so the probability of not picking or choosing F, G, or H is equal to the probability of choosing these other letters. Okay, so I think we are done with question 1 on probability. So let us proceed to question 2. Okay, question 2. One girl is chosen at random from 4 girls: Annie, Bonnie, Linda, and Dawn. Calculate the probability that one girl will be Annie, either Linda or Dawn. Okay, so possibility space, solution. So first of all, we should consider, or we should know our possibility space, or the set of outcomes we are expecting. We have Bonnie, Annie, Bonnie, Linda, and Dawn. So we can say that the number of outcomes here is simply 4. Number of outcomes, okay, outcomes, we can say it is 4. Okay, now then we are asked to say, find the probability that one girl will be Annie, either Linda or I mean either Linda or Dawn. So we find the probability of picking, okay, of picking Annie. The probability of picking Annie will be, okay, will be 1 over 8. Okay, 1 over 4. Sorry to say, this is the probability of picking Annie will be 1 over 4. Okay, and B, the probability of the probability of either Linda or John. So either Linda or Dawn. You can see here there are 4 girls: Annie, Bonnie, Linda, or Dawn. Now we just want to find the probability of picking either one of these. So the probability of picking Linda, it's 1 over 4. Okay, and the probability of picking Dawn, it's the same, 1 over 4. So they have equally same chances of being picked. Okay, so they equally have same chances of being picked. So if we add these probabilities, we have 2 over 4, which is half. Okay, which is half. Okay, so we are done with our second question on probability. I'm sure you've liked this video, and if you don't understand, you can try and rewatch the video, pause where you would want to solve. And thank you for your time. Thank you. Until next time on the same topic.